Hello everyone, welcome to lecture number 4. I am Dr. Hemat Ali Shah. Our course is Data Analytics and AI. In today's session, we will explore an essential and powerful concept in analytics. Data mining is a process of discovering patterns, trends, and useful insight from large data sets. It plays a critical role in AI and data analytics by helping businesses make informed decisions, optimize operations, and even predict the future trends, whether it is in retail finance, healthcare, or marketing. Data mining is a key drive of data-driven decision making. Why is data mining important? In today's digital age, organizations collect a vast amount of data, but raw data alone has no value unless we extract meaningful insight from it. That is where data mining comes in. Imagine a retail giant like Target Corporation using data mining to predict customers' behavior and personalizing marketing campaigns. Our financial institution leveraging data mining to detect fraud and mitigate the risk. These real world applications shows the power of turning raw data into actionable intelligence. In the next slide, we will discuss the agenda of today's class. So please keep watching. Okay, let's discuss the agenda of today's class. So first of all, we will start with the case study, Target Corporation, data mining in retail. Our discussions begins with a real-world example, Target Corporation. So we will explore how they use data mining to analyze customer purchasing behavior and create a personalized marketing strategies. Second, we gather and select data. Before performing any data mining, we need to gather the right data. In this session, we will learn how to identify, collect, and choose relevant data set for meaningful insight. N- Next, we discuss about data cleaning and preparation. Data quality plays a critical role in analytics. Dirty or unstructured data leads to inaccurate result. We will discuss the importance of cleaning and preparing data before analysis. Number fourth topic would be output of data mining and evaluating results. Once the data is processed, we get result, uh, but how do we interpret them? We will go over how to analyze data mining output and evaluate their effectiveness. Next, we go to the data mining techniques. There are multiple techniques to use in data mining, such as classification, clustering, regression, and association rules. We will explore different methodologies and their applications. Sixth topic would be a tool and platform for data mining. Which software and platform makes data mining easier. In this section, we will discuss popular tools such as Python, R, RapidMiner, and Weka that help in data mining process. Seventh topic would be data mining best practices, and eighth topic would be uh, the myths and mistakes that we normally make, and what are the challenges. And finally, we conclude the lecture with the key takeaway and summarizing the lecture. Please keep watching.
So we start what is a data mining. Data mining is the art and science of discovering knowledge, insights, and pattern inside the data. So there are three things that data mining is going to discover: knowledge, insights, and patterns. So data mining is both art and science, a powerful tool for discovering insights, patterns, and hidden knowledge within a data. It is the process of extracting useful and meaningful patterns from structured databases, enabling us to make information decision. These past pattern must be valid, novel means new, practical, and easy to interpret. As it is core lies the idea that past data holds clues. We can find lots of clues from the past data about future trends and behaviors. So future decision is based on the past data. Now the fields of DM data mining draws its strength from a range of other disciplines. For example, data quality in organizations, from databases management, advanced modeling and algorithm, from statistics and AI, and strategic decision making expertise from business management. To combine these fields, fuel the potential of data mining to address real world challenges. Okay, the field originated in defense, where it was used for tasks like identifying friends or foe on the battlefield. Over the time, uh, like many technologies with military origins, data mining found applications in business, offering competitive advantages in a rapidly evolving marketing place. For example, a grocery store identifying patrons such as customers who will buy cheese and milk also will buy bread. So 90% of the time this has happened. And this insights allows the store to optimize its product placements, boosting sales and enhancing customers' convenience or satisfaction. In healthcare, data mining can reveal life saving insights. For example, patrons might show the patients with a blood pressure over 160 and age over 65 have high risk of heart stroke. This knowledge will give information to doctors and they can prioritize timely interventions for the high risk patients. Predictive analytics is a cornerstone of data mining. One fascinating example involved modeling and the decision of Justice Sandra Day Corner in the U.S. Supreme Court. By analyzing her past voting patterns, researchers developed a simple four-step decision tree. This model predict her decisions with 71 percentage accuracy, outperforming legal analytics who manage just 59 percentage accuracy. Uh, test Testaments to the power of data mining is solving complex problems and issues. Okay, for improving prediction and gaining competitive edge in business to delivering timely diagnosis in healthcare, data mining enhance decision making across industries. It transforms raw data into actionable insight, creating ripple effects of smarter choices and better outcomes. Okay, to wrap up the slide, unlock the potentials of your data, discover patterns, predict outcomes, drive success with the data mining. Okay, in the next slide, we are going to learn about analyzing targets, data mining practices targets. A major retail chain uses data mining to understand customers' behavior and improve marketing. One of their models could predict if a customer was pregnant based on purchases. The story, a famous example, shows how this worked. Target sent baby related coupons to teenage girl. Her father, upset, went to the store saying, "My daughter is still in a high school." Why are you encouraging pregnancy? Later, he apologized after realizing targeting prediction were correct. Privacy concerns. This case shows how data mining can feel invasive. Customers often don't realize their data is being used this way, leading to privacy issues. Customers' trust, while affecting such practices, can damage trust if customers feel their private life are being exposed without their consent. Ethical question: should companies act on sensitive information like this? This is a question mark. Is it ethical to profile customers so deeply without telling them? Legal issues. Lastly, this raises question about data protection law and whether companies need clear rules for using customers' data. Then we conclude that the target cases. The target case reminds us that while data mining is powerful, business must handle it responsibly to avoid damage trust crossing ethical and legal lines. Okay, in current slide we are going to discuss about data management ecosystem. It consists of five different separate sections. So data is growing rapidly, doubling every 18th month and comes in massive volume, velocity and variety. To make sense of it, organization needs to structure process for managing data effectively. Number one process is called data gathering, which is a beginning of data collection. It starts by collecting relevant data. Not all data streams are equally valuable. Choose based on what suits your purpose. External sources like government databases, social media streams can also provide valuable insights. Second process is called data cleaning, which is very critical and it removes unwanted data and make data usable. Data often come in messy forms, unstructured data or semi-structured like blogs, videos, or LOT data. Cleaning ensures the data is usable by the organization and clear rows and columns for the further analysis. Third number section is called our process is called data organization. Data needs to be structured where we structure the data and store effectively. Most organizations use EDM, which is called enterprise data model, a unified system that organize internal data for easy access. Number fourth is the data warehouse. The EDM supports creating a data warehouse, a centralized place for storing and managing data. It simplifies selecting and deploying the right data for mining and analysis. Number fifth component in our ecosystem is called data mining. Once the data is prepared and ready for mining, this is where insights and are extracted, revealing patterns and trends for better decision making. So, managing data requires time and efforts, but when don't right, it transforms raw information into valuable business insights. Every industry and function will have a unique data requirement, and careful curation is key to success. So, based on the data, if the data is well managed, well clean, organization can make better decisions. Welcome to data cleaning and preparation process. A critical step ensuring the success of data mining projects. Without cleaning reliable data, even most sophisticated data analysis will suffer from classic garbage in and garbage out problem. Data quality varies based on its sources. Internal operation data is often more reliable with public or external sources such as social media. and it can be inconsistent or less accurate. Regardless of the source, cleaning and preparation data is non-negotiable process before analysis. This process typically consumes 60 to 70 percentage of the time in data mining projects involving several detailed steps we discussed below. Okay, number one, identifying duplicate data, redundant data. Duplicate data often arise when merging data sets from multiple sources. So, removing redundant entries ensure that results are not skewed or misleading. Missing values can disturb analysis. Depending on the context, they can be filled with average models or default values, or the affected rows may be removed entirely. Next, we have data elements should be consistent and comparable. Unit transformation convert matrices into the same unit. For example, cost, patients instead of total cost. Adjust for the time, normalize data for inflation or time periods. Then we have a data granularity. Data granularity align data resolution, for example, daily sales versus monthly compensation or common level. Next, we have a bin continuous values. Grouping continuous variable into categories make them easier to analyze. For example, work experience could be categorized into low, medium, and high. Next, we have remove outliers. Outliers, while sometimes valid on disturbed results, after careful review, exclude them to ensure more accurate representation of your data. Outliers are values that are more than maximum or less than minimum. Then we have correct biases. Check for representational biases in your data set. For example, if one gender is overrepresented compared to target population, adjust must be made for balance. Some data lack meaningful variability, diluting insight. Removing such data ensures that the remaining data set is more focused and informative. While labor intensive, these steps are foundations to create high level quality data, enabling effective analysis and meaningful insights. Without through cleaning and preparation, the power of data mining is significantly diminished. Let's dive into the output of data mining, which varies depending on the objectives being pursued. The representation of these outputs plays key role in making the results actionable and interpretable. One of the most common output is decision tree. This is a hierarchical branch structure that helps visually represent the steps for model-based decision making. Each branch may include attributes like probabilities, aiding in decision clarity. Tree or D tree can also be transformed into business rules. If then statements like if else that highlights casual representations. These are particularly effective when the objective is prediction, offering a clear path for actionable insights. A regression equation is another type of output representing the best fit curve for the data. These equations can include both linear and non-linear terms and are effective in forecasting future trends, representing output for classification exercises. For objective focus on next for objective focus on grouping data, the output might be a population centroid, a statistical measures that capture the central tendency of data points within the multidimensional space. Example include demographics like middle age, highly qualified educated, high net worth professional living in coastal areas. Behaviors such as 20 something teach entrepreneurs based on Silicon Valley. Even specific objectives like vehicle over 20 years old with a low mileage, failing environmental inspections. This type of output is often associated with the cluster analysis. Finally, we have now business rules are especially useful for market basket analysis. These are probability driven if then statements that reveals association in data. For example, if the customer buys milk and bread, there is an 80 percentage of probability they will also buy butter. So chances are 80 percentage. These outputs are like a key in retail, helping business identify patterns in customers' purchases. Now, let's conclude. The flexibility of data mining outputs ensures that they can align with the diverse objectives, whether it is prediction, classification, clustering, or association analysis. Each format, be it decision trees, regression equation, population centroid, or business rules, provide a unique lens to interpret and act on data. Okay, next we learn about evaluating data mining results. There are two primary kind of data mining process. Number one, supervised learning and unsupervised learning. Supervised learning, a decision model is created using past data, allowing for prediction on future data instances. For example, using time series data or past data, we can predict the future values. Next, we have a classification. The main type of supervised machine learning is a classification. Techniques decision tree are the most popular classification method where we classify things, whether this is subject A or subject B, or human or animal, cat or dog. So these are the classification. But many other techniques exist. Algorithm. Each classification technique can be implemented using various algorithms. Algorithm is the recipe, step-by-step solution of the problems. Then we have the how to evaluate the data mining techniques or matrices. Key matrices like predictive accuracy is a common matrices used for evaluation classification techniques. We normally use a precision recall F score to find the accuracy of the model, whether model is predicting accurate things or not. Supervised learning is essential when label data is available, making it useful for tasks such as a fraud detection, medical diagnosis, and spam filtering. In supervised machine learning, we train model or a classifier to predict values or to classify the values. Training is like teaching a baby a language where we have to show him everything, then first train the machine, then machine will predict the based on the training value and predict the accurate values. Yes, thank you. Okay, predictive accuracy in classification. Predictive accuracy is a common measure to evaluate classification model. It tells us how well a model correctly predict outcome. The formula is predict accuracy equals to correct prediction upon divided by total prediction, or we can say predictive accuracy equals to TP true positive plus TN true negative upon TP plus TN plus FP plus FN, where TP, TN, FP, FN stands for TP is a true positive and model correctly predicts positive cases. True negative RT and model correctly predicts negative cases. False positive, a model incorrectly predict positive when it is actually negative. And false negative or FN, model incorrectly predict negative when it is actually positive values. So these are the four parameters TPT and FPFN. Okay, let's see the example in case cancer diagnosis. A decision tree model is used to predict cancer in patients. If a cancerous patient is predicted as having a cancer, it is called a true positive TP. If a non-cancerous patient is predicted as not having cancer, it's a true negative. A patient has already a cancer, but the predictive model says not having a cancer. It's a true negative. Then, if a cancerous patient is incorrectly predicted as a healthy, it's a false negative because a patient having cancer it cannot be a healthy. Then we have if a healthy patient incorrectly predicted as a having cancer, it's a false positive. Importance of prediction accuracy. Higher accuracy means better model performance. Better accuracy, higher accuracy is model is performing very well. A good classification model typically has accuracy of 70 or more percentage in real world applications. Unsupervised machine learning, for example, clustering, does not have a fixed accuracy measure. As a result, it depends on how useful they are for decision making. Because supervised machine learning has these matrices, but unsupervised clustering doesn't have. Okay, understanding the data mining techniques. Data mining techniques can be broadly categorized into two main types: supervised and unsupervised. Supervised learning and unsupervised learning. Let's explore both in detail. Number one, supervised learning, predictive model. Supervised learning is when past data is used to train models to make prediction. The most common supervised learning technique include classification and regression. Machine learning. This method against assign data into predefined categories. A common example include spam email detection and medical diagnosis. Then we have a decision tree, a highly popular classification technique that is easy to interpret, automatically select important variables and work well when data with well with a noisy data. Then we have a neural network, a more advanced technique inspired by human brain used for complex patterns, recognizing tasks like image processing and speech recognitions. A classification is a statics regression is used to predict continuous numerical values such as forecasting stock pricing or estimating house prices. Number two, we have unsupervised learning or pattern discovery. Unlike supervised learning, unsupervised learning works with the data that has no predefined label. It helps in discovering hidden patterns and relationships. Uh, Clustering analysis is one example. This method groups similar data points together. It is commonly used in customer segmentation for target marketing. Then we have association rules, market basket analysis. This technique is used to define relationship, not define, but find relationship between items such as frequently bought together products in e-commerce. Okay, we discuss why decision trees are more important and what are their advantages. One of the most widely used classification techniques in data mining is the decision tree. It is favored for several reasons. Number one is easy to interpret. Decision tree present information in a visual like tree structure that is simple to understand. Number two, highly accurate. They provide reliable prediction when trained on good data sets. Number three, feature selection. Automatically select the most relevant variables. Number four, handle data quality issues. Works very well, even the missing or noisy data. Number fifth and last, support non-linear relationship. Can model complex pattern in data. Some of the most popular decision tree algorithm include C5, CART, and CHAID. Then we have a regression prediction, continuous value. Regression is another essential data mining technique, primarily used for predicting numerical values. The goal of regression is to fit the best curve or line to the data set, allowing for accurate prediction. Example, regression can be used to model energy consumptions based on daily temperature. If a non-linear trend is observed, non-linear regression techniques can be applied to improve accuracy. Key insights, the accuracy of regression model depends entirely on the quality and relevance of the dataset used, not on a specific algorithm or tool chosen. Next, we move into the artificial neural networks ANNS, Advanced Pattern Recognition. ANNS are sophisticated machine learning techniques inspired by human brain. These models process information through interconnected layers of the artificial neurons. How do ANNS works? A neuron receives input process it receives input and then process it and pass information to next layer. Network adjusts their internal weights based on feedback to improve accuracy. Some networks have a single layer while complex tasks require deep learning which involves multiple hidden layers. What are the advantages of ANNS? Can achieve high accuracy than human expert when trained on large dataset. Handle complex and high dimensional data effectively, works well despite data quality issues. There are also the challenges when we have the benefits. So, what are challenges we are facing? Yes, challenge number one requires large data set for training, considered a black box model, meaning its decision making process is not easy interpretable. When trained over long periods with extensive data, ANNS can outperform traditional models and application like image recognition, image processing, and financial forecasting. Next, we have cluster analysis, discovering natural patterns. Unlike supervised learning, cluster analysis is an unsupervised learning technique that groups similar data points together based on their characteristics. How does clustering works? Data points that are similar are placed into the same cluster. Dissimilar data points are assigned to separate clusters. Depends upon the n number of clusters. The number of clusters is often determined. Use the k-mean algorithm, which helps define meaningful groupings. For example, real-world application cluster segmentation for market strategies, medical diagnosis for to classify diseases, identifying fraud transactions in banking. Clustering is powerful tool that enables business to categorize and analyze large data set efficiently. Next, we discuss Association rules, market-based analysis, uh, market basket analysis. Sorry. Another key unsupervised learning method is association rule mining, commonly used in business analytics and e-commerce. What it does, identify affinities between items frequently purchased together, generates rule in the form of if x then y, where x and y represent set of items, doesn't have right or wrong answer, but rather a stronger and weaker relationship based on the confidence levels. Example, Amazon and Netflix recommendation product based on previous purchases. Example, customer who bought a laptop also bought a mouse. Streaming services suggesting movie based on the watch history. Famous discoveries, for example, a surprising association was found between the sales of diapers and uh, beer, leading to changes in the product's placement in the stores. Next, we discuss about tools and platform for data mining. With the rise of big data analytics, several tools and platforms are now available for data mining. These can be categorized as follow. Okay, we will take a deeper look at strengths, weaknesses, and best use cases for three popular data mining tools. Microsoft Excel, number one. Number two, IBM SPSS Modeler. And number three, Weka. We compare them based on the features like ownership, data mining features, standalone, user skill needed, user interface, data formats. So they are given in the uh, table, so you can learn more about them. We can see that Excel is commercial while IBM is commercial and expensive. Veka is open source and free. Then Excel is limited, extensible with 8 modules, while IBM is extensive, feature unlimited data size, which is good. Extensive Veka performance issues with the large data. Veka has the issues. Then we have Excel standalone, and it's like work independently. Embedded in BI software suites, and Veka is also standalone. Excel is end users. Anybody can use it, but IBM Modeler is for the skilled BI analytics, and same Veka for skilled BI analytics. Then Excel handles text and click easy, where IBM Modeler drag and drop use colorful, beautiful GUI. And graphical user interface also used in Veka and mostly between text and output. Excel is industry standard, variety of data is accepted, and proprietary is like Veka. Choosing the right tools for beginner or small scale data analysis. Excel is simple, widely used, but limited in data mining features. For professional analytics and enterprise solution, IBM SPSS is good one. Comprehensive, integrated with BI tools, but expensive. For research and machine learning application, Veka open source powerful, but may have performances issue with a large data set. Choosing the right data mining tool depends upon the project and scalability of the project. Also depend upon the project requirement, budget, and level of expertise. Okay, let's conclude this session with data mining techniques. Data mining is a powerful tool for extracting knowledge from large data set, whether we use supervised learning like classification and regression or unsupervised learning like clustering and association rules. Each technique has unique purposes. So we will learn key takeaways, decision tree, easy to use and highly accurate, regression used for prediction, numerical values. We remind it. Then we had neural network, advanced AI-based pattern recognition. Then we had clustering, identify natural grouping in data. After that, we had association rules, finding meaningful relationship between variables. After that, we had data mining tools. Different tools cater to different needs: Excel, IBM, SPSS, Veka. With the right data and techniques, business and researcher can unlock valuable insight that drive decision making and innovations.
Okay, so we start with the data mining process funnel or best practices for the data mining. So this you can see the topic data mining funnel. A data mining is a structured process that follows key stages to extract valuable insight from data. This funnel represents the essential steps in the data mining, moving from broad understanding to final implementation. Number one is step, you can see the business understanding. Here we align our data mining goal with the company's strategy. The key question to ask is what business problem we are trying to solve. A well-defined question ensures that data mining delivers real values. Next, we move to data understanding. This step involves identifying and exploring relevant data sources. We need to ensure that we have the right data available to answer our business questions effectively. And next, we move to the data preparation. Once we have our data, the next step is data preparation. This is one of the most time consuming step to make it suitable for analysis. A well prepared data set leads to a better model performances. So next step is data modeling. It is the core of data mining. This step involves applying machine learning algorithms and statistical techniques to test hypotheses and identify patterns in the data. Choosing the right model is crucial for making accurate prediction. After modeling, we must evaluate our result. This step checks if the model is performing well by validating its accuracy and reliability. If the model does not meet expectations, we refine and improve it until we achieve the desired performances. This dissemination and rule out. Finally, the insight must be implemented in business operation. This is step called dissemination and roll out ensures that findings are shared with the stakeholders and interpreted into decision making process. Um, this structured approach ensures that data mining is effective, reliable, and impactful. By following these steps, businesses can turn raw data into actionable insights, leading to a better decision and improve outcomes. Okay, in this slide, we are going to focus on understanding the data mining myth and key consideration. Data mining is a powerful tool that helps business uncover hidden insight, make data-driven decisions, and gain competitive edge. However, before adopting data mining, business must address common misconception and key consideration to ensure success. Part one myth about data mining. Data mining is only about algorithms. Many believe data mining is all about complex algorithms, but the real value lies formulating the right business questions. The most successful project starts by identifying the problems, defining clear objectives, and testing practical hypotheses. Algorithms are just tools. Having a strong problem statement is far more important. Myth number two, data mining is only about predictive accuracy. While predicting accuracy is a useful matrices, it should not be sole focus. The success of data mining projects depends on the quality of the data, the relevance of the problem being solved, and effectiveness of the business insight. A model can be highly accurate but still fail to provide meaningful value. Myth number three, data mining requires a data warehouse. Some think a data warehouse is necessary before starting data mining. While a well-organized data warehouse can make a data access easier, it is not a strict requirement. Business can conduct valuable data mining using structured or unstructured data from various sources even without dedicated data warehouse. Myth number four, a mine requires large quantities of data. Many believes that massive data sets are needed for data mining to be effective. In reality, small to medium-sized data sets can still provide valuable insights. The focus should be on the data quality or quantity. Well prepared, relevant data can generate significant business value. Myth number five, data mining requires a technology expert. Another common myth is that only data scientists or IT specialists can perform data mining. While technical expertise can be helpful, many business professional analytics and executives successfully conduct data mining using everyday tools like spreadsheets, visualization softwares, and automated platforms. Now we are going to discuss on this particular slide. Should we adopt data mining in our business or not? Focus on problem statement. The first step before implementing data mining is defining the right business problem. Business must ask, what decision do we need to improve? What insights are we seeking? A well defined problem leads to better solutions. Then we discuss about data ware necessity. While having a data warehouse can improve data organizations, it is not mandatory for a data mining. Some businesses starts their data mining journey by working with a raw or fragmented data set before building a formal data warehouse. Next, we see the predictive accuracy. Predictive accuracy is often highlighted as a key measure success, but it should not be the primary focus. Instead, business should aim to extract actionable insight that drive real business value, even if predictive models are not perfectly accurate. Then we have a data quantity. Okay, data mining. Data quality, a common misconception is that bigger data set always lead to a better results. However, quality matters more than size. A well-structured, clean, and relevant data set, regardless of its size, can provide meaningful insights. We know that. Data mining is a powerful business tool, but success depends on asking the right question, using available data effectively, and focusing on insight rather than just algorithm or large data set. By debunking myth and following best practices, business can unlock valuable intelligence, enhance decision making, and gain competitive edge in the market. Adopt data mining with the right mindset and let data drive your business forward. Let's conclude this lecture. Common mistakes in data mining. Data mining is a powerful. Okay, common mistakes in data mining. Data mining is a powerful tool for extracting meaningful patterns from data. However, without the right approach, common mistakes can lead to waste of time, poor insights, and ineffective decision making. Let's explore some of the most common mistake business makes in data mining and how to avoid them. Mistake number one, poor goal setting. One of the biggest mistakes in data mining is failing to define clear objectives without well-defined goals. Businesses risk solving the wrong problem or focusing on irrelevant insight. A strong data mining project should align with the business needs and deliver real value. Common issues: number one, lack of business objectives. Number two, selecting the wrong problem to solve. What are the solutions? Solution is clearly define the problem statement and ensure it aligns with the business priorities. Mistake number two, lack of the business knowledge. Data mining is not just about running the algorithm, it requires domain expertise. Without a deep understanding of the industry and business context, the result can be misleading or misinterpreted. Common issue, insufficient domain understanding, ignoring suspicious finding. What would be the solution? Involve business experts to interpret result and validate insights. Mistake number three, poor data management. Having lots of data doesn't mean that the right data. Without proper data organization, team can get lost in irrelevant data points leading to unreliable results. Okay, common issues can be disorganized data process and then lack of the metadata, sorry. Solution: maintain clean and well-structured data to ensure metadata is available for proper analysis. Mistake number four, tool compatibility issues. Using incompatible tools can create technical challenges in data integration, visualization, and interpretation. A smooth workflow requires seamless coordination between different data mining tools. Common issues: over reliance on aggregate results, incompatible tools and data sets. A solution: choose tools that can be handle multiple data formats and integrated well across different platforms. Let's conclude. Data mining is like finding a gold in a mine. It requires patience, skills, and a right approach. By setting clear goals, ensuring a strong business knowledge, managing data effectively, and using compatible tools, business can avoid common pitfalls and maximize the value of their data mining efforts. The key to success is aligning data insights with the real business objectives. So keep your goals in focus, engage with the data critically, and always be open to unexpected insight. So thank you very much. This is all about data mining lecture number 4. We end this chapter. Thank you for watching.